the previous lecture, we considered an electron moving in a plane in the potential V r equals minus k r, which is minus 1 over 4 pi epsilon 0 z e square over r, and found that the energies came out to be precisely the same as that in the Bohr model. However, what was new in this was that for the same energy values, we also obtained orbits which could be of different values. So, for example, suppose these 3 orbits have all the same energies and have angular momentum L1, L2 and L3, we found that L1 is greater than L2 is greater than L3, because the different angular momentum are different and the energies are the same. So, we included the possibility through quantum numbers, right, that orbits could be of different kinds. So, what we saw was there could be more than one orbit for the same energy, and the relationship between two quantum numbers, namely nr and n phi, gives the energy and the type of orbit. So, this was kind of quantum mechanics being developed, still the old quantum theory, but why I am doing all this is what you will see is that the ideas that later the true quantum mechanics gave, the answers that the true quantum mechanics gave, those ideas were already setting in through older quantum theory, and that is why I am doing this, the previous lecture and this lecture devoted to old quantum theory. Next going to consider is 3-dimensional case, and in the 3-dimensional case what happens is this orbit need not be confined to only xy plane. There is a possibility that the orbit could be tilted, it could be even more tilted. So, this tilt is going to bring in a new quantum number, an additional third quantum number. So, the possibility we are considering is that the orbit could also be tilted with respect to the xy plane, and that tilt is going to be decided by a third quantum number. So, for that we will now consider a full 3-dimensional motion of the electron around a nucleus, which also can be called the application of quantum conditions to an atom. This is the full glorified 3-dimensional view. So, in this case the energy, I am going to use spherical coordinates, and the energy E is going to be given by 1/2 mr dot square plus 1/2 mr square theta dot square plus 1/2 m r square sin square theta phi dot square minus k divided by r. So, now there are going to be 3 to be 3 generalized momenta. And what are these? These are P r, which is partial E over partial r dot, which is m r dot. This is P theta, which is partial E over partial theta dot, which is m r square theta dot, and this is P phi, which is equal to d E by d phi dot, which is m r square sin square theta phi dot. And what are these? This you can see is connected to motion along r and has the dimension of linear momentum. The second one is dimension of angular momentum. And so does the third one. But what are their interpretations? So, let us see what angular momentum of a particle moving in 3-dimensional is. This is r cross mv, which I can write as m, r is r unit vector cross the velocity, which is r dot r plus r theta dot theta plus r sin theta phi dot phi. When you take this cross product, this comes out to be m r square theta dot r unit vector cross theta unit vector plus m r square sin theta phi dot r unit vector cross phi unit vector. And this is nothing but m r square theta dot r unit vector cross theta unit vector is phi unit vector. R unit vector cross phi unit vector is minus theta unit vector. So, minus m r square sin theta phi dot theta unit vector. Let me remind you from your previous courses that phi unit vector is nothing but x unit vector sin phi with a minus sign plus y unit vector cosine of phi, and the theta unit vector is nothing but x unit vector cosine of theta cosine of phi plus y unit vector cosine of theta sine of phi minus z unit vector sine of theta. So, if I substitute these in, let us do that, then the angular momentum vector L comes out to be m r square theta dot, let us put phi unit vector minus x sin phi plus y cosine of phi minus m r square sin theta phi dot theta unit vector. So, starting from the expression L is equal to m r square theta dot phi minus m r square sin theta phi dot theta. I am now going to show you that P phi is equal to nothing but the z component of L, and L square is nothing but P theta square plus P phi square over sin square theta. So, let us do that. If I take the z component of L, it is 0 from phi phi gives you 0 contribution from for the z component, minus mr square sin theta phi dot, and the z component of theta is minus sin theta z. So, this comes out to be mr square sin square theta phi dot z, and this is nothing but p phi. So, what I have shown you is p phi is nothing but Lz, and from the expression for L, which is mr square theta dot phi minus mr square sin theta phi dot theta, I can write this as p theta phi minus p phi over sin theta theta. Theta and phi are perpendicular to each other. So, this immediately implies that L square is p theta square plus p phi square over sin square theta. So, let us see what we have found. We have found that the energy for 3-dimensional motion of an electron around a nucleus is going to be given as 1/2 r dot square plus 1/2 mr square theta dot square plus 1/2 mr square sin square theta phi dot square minus k over r, and p r is mr dot, p theta is mr square theta dot, and p phi is mr square sin square theta phi dot, and this is nothing but Lz. And p theta is such that L square, that is the angular momentum. I am using L for angular momentum. L square is p theta square plus p phi square over sin square theta. Right. So, we have found this so far. Now, for central field motion, meaning when V is of the form 1 over r, the force is central, L is conserved, and this means all components of L are conserved. Right. So, what that means is L square, which is equal to p theta square plus p phi square over sin square theta, is a constant throughout the motion, and Lz, which is p phi, which is mr square sin square theta phi dot, is also a constant. So, now let us apply quantum conditions. And what do these give? The easiest to apply is p phi d phi, which is nothing but this constant Lz times 2 pi should be equal to n phi times h, or Lz is equal to n phi h cross. That is one. Quantum condition for p theta is going to be integral p theta d theta, and we will see what the limits of this are going to be, which is equal to integral square root of L square minus Lz square over sin square theta d theta over this period is going to be equal to n theta h. All right. And now, Lz is z component of L, angular momentum. Since Lz is z component of L, it means that modulus Lz has to be less than or equal to L. Now, let us look at the integral square root of L square minus Lz square over sin square theta d theta. Now, if you want L square minus Lz square over sin square theta square root to be real, then L square minus Lz square over sin square theta is greater than or equal to 0, and sin square theta has to be greater than or equal to Lz square over L square, and sin theta is then limited to minus Lz by L modulus to modulus Lz by L. And therefore, this integral from here becomes integral sin inverse mod Lz over L to sin inverse theta equals sin inverse mod Lz over L square root of L square minus Lz square over sin square theta d theta. Again, we are not going into how this integral is calculated, but its value comes out to be, after you perform the integral, it comes out to be 2 pi L minus mod Lz. So, what we have found is integral p phi d phi is equal to n phi h gives you Lz equals n phi h cross, and integral p theta d theta gives you 2 pi L minus mod Lz equals n theta h, or L minus mod Lz is equal to n theta h cross, or L equals mod Lz plus n theta h cross, which is n phi plus n theta modulus h cross. So, what we have found is that the angular momentum z component of angular momentum is equal to n phi h cross, and since this is z component, it could take negative or positive values both. So, I am going to say n phi could be 0 or positive or negative integers. They are integers, but they could take positive or negative values. L, which is the magnitude of angular momentum, is going to be equal to n theta plus modulus n phi h cross, and you can see that n theta should take values of 1, 2 and so on. So, that even if n phi is 0, there is a possibility of n theta having the angular momentum being finite. We are excluding 0 angular momentum. So, this is, now we have got two quantum numbers, n theta and n phi. N theta is related to the n theta plus mod n phi is related to the total angular momentum, and n phi is related to the z component of the angular momentum. So, let us just again summarize. Lz, which is p phi, is equal to n phi h cross, and n phi is 0 and plus minus 1, plus minus 2 and so on. L, which is the magnitude of total angular momentum, is going to be n phi modulus plus n theta h cross. So, this is equal to, let us call it k, h cross, k equals 1, 2, 3 and so on. Since we found that L z modulus is less than or equal to L, this necessarily implies that mod n phi h cross is less than equal to k h cross, or n phi is confined between minus k and k. What that means is that you could have a net angular momentum k h cross, and it could be in a direction which is in the z direction. Next, it could be, so this will be k h cross, or it will be k minus h cross, so that the angular momentum is pointing in certain direction. It cannot be any arbitrary direction. The projection has to be k minus h cross. Third, I could have this k h cross, and the z component would be k minus 2 h cross. I am just drawing these symbolically, these angles are not written to the precise. In fact, k minus 2 h cross, if I were to show, it will be like this, and the angular momentum would be at a larger angle. So, this is k minus 2 h cross, k h cross. Not only that, it could be in the opposite direction. So, if I were to draw to the scale, even the first one would not be like this. Instead, it will be that k h cross is right along k h. It could also be in the opposite direction. The net angular momentum could be the other direction, and magnitude remains k h, and the z component could be minus k h cross. I could also have k minus 1 h cross with a minus sign, and the angular momentum pointing this way, k h cross. I could also have the angular momentum k minus 2 h cross in the negative direction, and the net angular momentum pointing this way. So, what this is showing is some sort of a space quantization, that the orbits are such that they could be either in the x y plane, or they could be tilted, but they cannot be tilted arbitrarily. They would be tilted such that the z component is still an integer multiple of h cross, and the total angular momentum remains the same. So, we have found two quantum numbers, n theta and phi, related to the total momentum and z of angular momentum. I am still to do P r dr to be equal to n r h. Let us do that now. So, remember, energy was equal to 1/2 m r dot square plus 1/2 m r square theta dot square plus 1/2 m r square sin square theta phi dot square minus k over r, and quickly I can write this as P r square over 2 m plus P theta square over 2 m plus P phi square over 2 m sin square theta minus k over r, and you can see from what we derived earlier, this is nothing but equal to P r square over 2 m plus L square over 2 m r square minus k over r. So, I have the energy given as P r square over 2m plus L square over 2 mr square minus k over r. So, Pr is given as square root of 2me minus L square over r square plus 2 mk over r, which is exactly the same expression as I had obtained in two-dimensional case. So, this is exactly the same expression that we had obtained in 2D case. Let me write in the previous lecture. So, it will give me exactly the same answer if I do integral P r dr equals n r h. I will urge you to go back to that lecture and I will get exactly the same answer, E n equals minus m k square over 2 n square h cross square, which is same as minus m z square e raised to 4 over 32 pi square epsilon 0 square h cross square n square, where n now is going to be n r plus n theta plus n phi. That is the value of n, and n r, because n minimum is 1, could be 0, 1, 2 and so on. So, what I have shown through this lecture in this is that if we allow full 3D motion, what happens? 1, E is given as 1/2 mr dot square plus 1/2 mr square theta dot square plus 1/2 mr square sin square theta phi dot square minus k over r, and the quantum conditions are P r dr is equal to n r h, P theta d theta is equal to n theta h, and P phi d phi is equal to n phi h, and we have found that n r would be 0, 1, 2 and so on, n theta would be equal to 1, 2 and so on, and phi will be 0, plus minus 1, plus minus 2 and so on. More importantly, what we have are now 3 quantum numbers. Through this, we also found that mod of n phi was less than or equal to n, where n is equal to n plus n theta plus mod n phi, because z component has to be less than or equal to the total angular momentum. So, we found 3 quantum numbers. Third, the energy E n comes out to be exactly the same as Bohr model E v, but now the possibility of an orbit having energy E n being unique is gone. What we could instead have is that different orbits with different quantum numbers nr, n theta and n phi could have the same energy E n depending on n r plus n theta plus mod n phi. So, this gives that an orbit has 3 numbers which I could write as n, which is same as n r plus n theta plus n phi, k which gives the total angular momentum, and n phi, mod n phi being less than equal to k. So, these are ideas. I am just doing it to introduce you to the ideas how the idea of quantum numbers arose from these quantum conditions, and these are going to lead us to understand the quantum nature better and better. Calculations, I am going to give you some simple calculations based on Wilson Sommerfeld quantum conditions, which are in use today also. And what you will see later when the full quantum mechanics comes into being, when we start solving problems with that how close to true quantum mechanics these ideas came. What is important and what I am going to cover in the next lecture is, having these 3 quantum numbers now, people tried to explain the spectrum of different atoms and also the periodic table, and came up with the concept of electron spin.